You are. And welcome to the MPI context-based audio enhancement, MPI-CAI presentation. Specifically today, we'll be addressing version 2.1, which is now out for comments. I am Marina Bozzi. I'm chairing the MPI-CAI development group, and I'm affiliated with the CCRNA Center, the Computer Research Center at Stanford University. Leonardo will, after my presentation, give you an overview of the whole MPI structure, our achievements, and a look towards the future. So MPI-CAI was born out of the need of maximizing the experience of audio for the listener, for the ultimate user. So the idea is that we are trying to improve the user experience by exploiting the information which is given to us through the context of the audio experience. And because of that, we're able to maximize and improve, enhance the audio content for consumption. So the idea is that we're looking at different scenarios. It's not just one static implementation. We're looking at the situations in the home, in the studio, on the go, in the theater, and so on and so forth. So far, especially for version 1.4, we have identified and implemented, for most of the use cases, we have software implementation available, 4 use cases. Version 1, in fact, 1.4, to be really precise, was also adopted at the end of 2022 by the IEEE Standard Organization, and that is IEEE 3302-2022. So that shows also the outreach of the MPI standard work. We are not just doing our own little homework, but it's has been vetted and approved and adopted by a pretty important international organization like IEEE. So let's talk about version 2.1. I did a couple of presentations in the past about the specific for use cases and so on and so forth. But 2.1 concentrated on a couple of things. One, we introduced a new composite AIM, the audio scene description, ASD. And what's interesting about this AIM is not only is part of the MPI-CAI specification per se, but it's also incorporated in other MPI standards, and I'm sure Leonardo will touch on those. And what's new, and it's, I would say, quite remarkable, is the fact that the standard now is organized in a much more consistent way, if you wish, and much more accessible. It's web-based, and all the standard specification can be easily found now just by clicking on whatever we're interested in double checking. So going back to the audio scene description composite AIM, it's a rather complex AIM, as hence the name. There are different stages included in this particular AIM. And by the way, AIM, for those new to the MPI jargon, stands for AI module. The AI module is the core of the AI workflows in MPI. But here we have different stages in this composite AIM. We start with analysis transform. We go from the time domain to the frequency domain. In the frequency domain, we have a specific source localization. Spatial attributes are then included in the signal, and separation and enhancement of the different audio sources is applied. Then from the frequency domain, we go back to the time domain through the synthesis transform, and finally, the packager includes both the enhanced source and whatever information is related to the recording mechanism through the microphone array. So having said that, this is a specific example, for example, for an audio conference where we have different speakers, and each speaker is associated, in this particular case, with a speech object, but more in general, we'll call that audio object. So we have the microphone array positioned in such a way that it can detect the different objects, content, and location. And therefore, we have a series of audio streams, if you wish, that will help build the audio scene description. So in output, we have audio objects with their associated locations. So that's kind of like the functionality of the new composite AIM. I mentioned also that the structure of the standard has been basically completely reconsidered and redesigned. We have a new web-based organization of the standard specification. And what do we specify? In MPI, we have the normative, which is the workflows connections and the functions of the different AIW within the different AIWs of the different AIMs. So we don't specify how to implement an AIM as long as it has the same functionality and the output and input data are in line with the MPI specification. Furthermore, for the input and output data, we specify the semantics and the syntax. So this is an example of data format in version 2.1. For example, if I click on the audio object, and now I'm going to stop sharing and see if I can see, yes. Okay. So here we have the definition, the syntax, and the semantics. What does the syntax say? Well, it specifies a header where the standard, the version, and minor version are described. The audio object data, so of course, sampling rate in between 8 and 192 kilohertz, sample types, which is really the sample precision in between 8 bits and 64 bits, and so on and so forth. So just by one click, you can actually reach both the semantics, but also the syntax. Here we have a JSON file, and I'm stopping again. This is probably not the most illustrative JSON files, but just to give you an idea of the structure. Let's see, share screen. Here, you have the JSON file that describes the audio object and so on and so forth. So this is like, at a high level, the new organization of the MPI standard, but not just of the MPI standard, also of other standards that were recently specified within MPI. And I'm sure Leonardo will go over all of that. We have a number of data formats that are used not just in the audio scene description, but also in other use cases. For example, the audio recording and preservation, ARP, EAE, the enhanced audio conference experience, and so on and so forth. So everything got restructured in this, following these guidelines. As I was mentioning, there are all the use cases covered. For example, the first one is emotion enhanced speech, KAES. And again, I have to share screen. Here, this is an example of the high level description of the use case, the function, the reference architecture, the IO data and workflow, function of the different modules, data, and AIW, AIM's JSON files. So here you have all the information just a click away. So going back to the presentation, this is quite remarkable, and it took quite an enormous amount of work to standardize every single use case, and for that matter, specifications in this matter, but I think it's very, very dynamic and effective. As I mentioned, in MPEG Chi version 1.4, we had 4 use cases. So the emotion enhanced speech, Chi ES, audio recording preservation, Chi ERP, speech restoration system, Chi SRS, and enhanced audio conference experience, Chi EAE. And the new composite AIM is part only of 2.1. And that is the audio scene description, Chi ASD. So in conclusion, I would like to also congratulate founding member Audio Innova for winning for the consecutive year the very prestigious Cannes Neurons Award at the World Artificial Intelligence Cannes Festival. That's probably the biggest, if not one, and the most known maybe at this point, but certainly the biggest festival on artificial intelligence, and winning not once but twice is pretty remarkable. The award is honoring the most innovative and impactful AI projects in the world. So there was participation throughout the world. And the honor that was bestowed to Audio Innova was in recognition of the best creative AI for the development and the impact of the technology behind MPI Chi ARP. So congratulations. I couldn't finish this talk without mentioning our latest work items, and the most prominent, and I have some of the proponents here, so if you have specific questions, I'm sure they can address it, is the 6 degrees of freedom audio, 6DOF, and that is an extremely important step in the direction of immersive audio. So we're very proud to look at it from the lens of AI. And with this, I would like to thank all the people involved in the work, certainly not just my work, but a full team of contributors were part of this journey. And specifically, I would like to thank Sergio Canazza of Audio Innova and University of Padua, Mert Koteli, Aselsan, Hussein, Metu, Alessandro, and Matteo of University of Padua, Mark, and Fatih from SMI, Speech Morphing Incorporated. So with this, I thank you for your attention. And I guess we always conclude our talks with the hope to continue working with you or start working with you. We look forward to having more and more exciting projects within MPI Chi. And for this, I'll ask you to take a close look to the MPI community website and join the fun. And this will conclude my presentation. Thank you very much for your attention.